Determine whether the following integrals are convergent and evaluate any that are convergent. So the first one we have here is the integral from 1 to infinity of 1 over x to the power 4. So I'm going to do that as 1 to a, and of course 1 over x to the 4 is x to the negative 4. So increase the power by 1, divide by the new power, and then we'll tidy that up. So that is going to be negative 1/3 and 1 over 3x cubed. That would be a nice way to write that one. And so using the top limit, we have negative 1 over 3a cubed, and using the bottom limit we get negative 1/3, and we could tidy that and make it into 1/3 take away 1 over 3a cubed. And if we look at the limit as a tends to infinity of 1/3 take away 1 over 3a cubed, this one would just go to 0 and we would get 1/3. So that one converges quite nicely and evaluates to 1/3. Now the next one is the integral from 1 to infinity of cos x dx. So let's do that as 1 to a of cos x dx, and of course cos integrates to sine x. And so what we'll get there is sine a take away sine of 1 radian. Now if we consider the limit as a tends to infinity of sine a take away sine 1, we don't get any convergence there. And the reason is that we know that sine a is just going to continue doing this. So it's never going to go to a particular value. As we make a larger and larger, it's just going to fluctuate between negative 1 and 1. So now let's look at the next one, which is the integral, and we'll do that as 1 to a of 1 over x dx, and that's going to be ln mod x from 1 to a, which is ln a take away ln 1. Of course ln 1 is 0, so that's just ln a. But there is no limit as a tends to infinity of ln a, so this one's not convergent either. If you think about the log graph, the gradient gets less and less, but still every time you increase x, you increase log x. So there is no convergence. And finally, we have the integral from 1 to infinity of e to the negative x dx, and of course we'll put an a there to start with, and that's going to be negative e to the negative x from 1 to a, which is negative e to the negative a plus e to the negative 1, which we could write as e to the negative 1 take away e to the negative a. And then let's consider the limit as a tends to infinity of e to the negative 1 take away e to the negative a. Well, in this case, this one is going to go to 0. Think about e to the negative x. Well, that's going to go down like this, and we'll asymptote to the positive x-axis. So when a gets large, this is going to go to 0. And therefore, that would just be e to the negative 1.